Hello everyone, in this video given as a semicircle having diameter is equal to 18 units. We divide it into two parts by a line segment. One is this segment and other is this portion. If this angle is of 30°, then by this limited data we have to find the area of this orange shaded segment. Let me move toward the solution. First of all, we mark the center point of the semicircle. Since diameter is 18, so radius of this semicircle is of 9 units. We draw a line segment from this center point to this point. This is again a radial line of the semicircle and have length is equal to 9 unit. Here we have this triangle in which two of its sides are equal in length. So this is an isosceles triangle, means if this angle is of 30°, then this angle must be of 30°. Since we know that sum of the interior angle of a triangle are 180, so this 30 plus 30 is 60, and thus this angle is of 120°. We know that area of a segment is equal to area of this sector minus area of this triangle. So area of the sector can be given as pi r square times theta over 360° minus area of triangle is equal to, this triangle is equal to 1 over 2 r square sine theta, where r is the radius of this semicircle. Substituting the value of radius, which is 9, and angle theta, which is 120°, so this will be pi times 9 square multiplied by 120° over 360° minus half time 9 square sine of 120°. 9 square is 81. This will be cancel out and here we will get 3. 9 square is 81 and this will give us pi times 81 over 3 minus 9 square is again 81 and sine 120° is square root of 3 over 2. So this will become 27 pi minus 81 times square root of 3 whole divided by 4. So using calculator we have area of this segment is equal to 49.749 square units. That is the answer. Thank you for watching.